Welcome back. I learned from CNN that you should always start saying back to the studio in Atlanta, but the studio is today in Lund in Sweden, not in Atlanta in Georgia, but it's almost the same. Very welcome back. The next session starts with a very important presentation from Professor Antônio Benetti from the Federal University of Rio Grande do Sul, who will talk about future water treatment in the public sector. Antonio, please, the floor is yours.
So are you seeing my presentation?
Sorry, yes, yes.
Okay, so then I will start. I will prefer to talk in English. I hope the interpreter can understand my English, but since I wrote the slides in English, I will present in English. So I'm Antônio Benetti, and I'm professor at Universidade Federal do Rio Grande do Sul, Instituto de Pesquisas Hidráulicas. NESA is our research group in basic sanitation and environmental sanitation. So I thank Kenneth for the invitation to make this presentation. He asked me to talk about future water treatment in the public sector. I will start with a definition of basic sanitation in Brazil. When we say sanitation in Brazil, we mean drinking water, wastewater, solid wastes, and urban drainage. In Europe and North America, sanitation is wastewater only, but in Brazil, it's different. In Brazil, the providers of drinking water are mostly public, a public service provided directly by the municipality or a company owned by municipality or a state-owned company. And then there are some private companies contracted by municipalities and in small participation of social organizations. But so here we have the providers, public provider are 93% of the service, and private is 6.8, and other just 0.2%. But the major provider are state companies. 28 state companies, state government companies, they supply water to 78% of municipalities and 70% of the urban population. Almost every state in Brazil has a state-owned company for providing sanitation. Here are 3 examples. But probably this will change a little bit, because in July of 2020, Brazil enacted a new sanitation law. And in this sanitation law, the concessions of the services will be made by bid, allowing public and providers and private providers to offer this service. And also for small municipalities, they can form blocks to make the service financially sustainable. And the objectives are of the new basic sanitation laws is that by 2033, Brazil has 99% of the urban population with drinking water service and 90% of the population with wastewater collection and treatment. And in this map, we see according to the color, we have we have the percentage of population served. For instance, this blue, dark blue, it means that more than 90% of the urban population have access to drinking water. But we have a lot of problems with even in these states where 90% have provision of drinking water. In Curitiba right now, we have a shortage of drinking water. It's 36 hours with water and 36 hours without water. I think Sergio mentioned this, because the reservoirs are just dried because of droughts. No. And in Rio de Janeiro, in summer months of 2020, so the population received poor water quality like this, with a lot of turbidity, taste and odor, sometimes detergent. And this was not 1 week, it was 2 or 3 months. And right now, in Amapá, which is in the north state, there was a fire in the electricity substation. And for 2 weeks now, the population doesn't have drinking water. And as Sergio mentioned also, and I think Rafael will talk about this, the supply, the water supply network, it suffers from problems with water loss. The average water loss in Brazil is 38.5%. So it means that 100 liters that leave the treatment plant, about 38 liters, for 100 liters that leaves the plant, 38.5, it's not accounted. It's huge. And well, I think the 4 cornerstones of good quality drinking water, there are 4 cornerstones. The first one is protecting the water resources. It should be like this, but frequently we have like this, you know, and many times between them. And then the second cornerstone is drinking water purification. So the drinking water treatment plant should have the capacity to remove pollutants that are in raw water. And it can be large treatment plants or can be smaller, like this one, which is direct filtration, or can be even a chlorination for well water. So the third cornerstone is maintaining infrastructure. Water is the universal solvent, so it reacts with everything, and it reacts with piping and fitting materials. And sometimes it can make pipe like this with a lot of corrosion and biofilms. So it's very important maintenance. And the last cornerstone is inside households. Sometimes water gets polluted inside the buildings. Like this is a pipe from inside a building. This is a reservoir, water reservoir inside a building without lid and corroded. So let me talk about the future water treatment in the public sector. So I think we have these international directions that United States Resolution 64/292, it says that safe drinking water is a human right. So everyone has a right to have safe drinking water, to enjoy fully his or her life without diseases. And so this is well known for thousands of years. Now, this is in Turkey, a water fountain that's still working. It's 2,700 years old. I hope someday I can visit this place. And also, as international direction, the United Nations Sustainable Development Goals, the goal 6, clean water and sanitation for all. And in Brazil and for other countries, now this safe drinking water for all, it's related to other goals like sanitation for all, which is related to better water quality. Also, we need more efficient water use. I mentioned the example of water loss. Integrated water management, we need to protect the water sources. Healthier ecosystem, because it's related to our own health, the healthier ecosystems, and also international cooperation and local participation. And in Brazil, I think the utilities will have to focus in this new basic sanitation law that I just mentioned, and Sergio also mentioned, that it will have regulatory settings. It will set regulatory standards for the services. And also in Brazil, we have the National Basic Sanitation Plan. It was enacted in 2014, and now it's under revision. It will published again in 2020. It's very ambitious plan. The objective was to bring water to 99% of the population in year 2030. And it's supposed to allocate billions of reals to achieve this, but it never happened. Brazil is good in setting objectives, ambitious objectives, but then it's not very good in achieving them. And also we have now the National Rural Sanitation Plan. About 75% of rural population in Brazil, they don't have access to safe drinking water. And so the goal of this plan is to achieve 96% household supplied by safe water distribution systems with in-house piping by year 2038. And also the utilities must look at the drinking water quality standards for the Ministry of Health. In 2020 or 2021, we will have an updated version. And this water quality standard sets maximum concentrations for chemical pollutants that causes health problems and microorganisms that cause disease and taste and other concentrations.
1 minute, please.
Okay. What happened?
Please, you have 1 more minute to present.
1 more minute. Okay, so I have to be faster. Okay, so okay, so we have the surveillance information for system for drinking water, which is a database. We have this water law, a regulatory agency for with competence to define reference standards. And the major challenge for the first, bring water to 35 million Brazilians without access to it. Improve drinking water quality in rural areas. Keep consumers confident in the quality of drinking water. Otherwise, they will start using bottled water. Apply technologies to remove pollutants that are not taken by conventional treatment, such as taste and odor, toxins, and pesticides. Improve processes to decrease biodegradable organic matter in drinking water, which causes biofilm growth in the distribution systems, like this biofilm growth. Minimize water shortage, intermittence, and outage in water supply, because it affects the drinking water quality. Improve efficiency to compete with private providers and adapt to climate change, which will bring floods, droughts, salinity intrusion, increased organic matter, algal blooms. And these are the impacts of global warming. So I thank you for your attention. This is my email. This is our research group with the Instagram and Facebook and LinkedIn. Thank you.
Thank you very much, Antonio, for an excellent overview and the number of areas where we could apply innovation is happily large. So there's lots of things where we could contribute. I'm checking if we have some chat or questions.
Vilka innovationer pågår för den brasilianska vattensektorn?
So we have one question here from Lund, and it asks to you, Antonio, which Brazilian activities are happening now in the area of water innovations?
Okay, so the innovation in Brazil, I think will go especially in the molecular biology for identification of harmful bacteria and virus in drinking water, focusing on online identification, and also in material science to develop new materials for use, for instance, in on-site drinking water treatment or for emergency drinking water treatment. And also, yeah, I think this is the two main areas at this moment. So at also, how do you say, identifications of water loss in public network supplies too.
No. Thank you very much. I can say I've been having opportunity to be guest professor in Porto Alegre at the Federal University of Rio Grande do Sul, and the tap water I had in my flat was a safe water, and it never felt threatening to use it as a drinking water. But I have to say the taste was maybe not the finest I've ever tried. There were some chlorination byproducts, which of course indicated that the treatment plant used good disinfection using chlorination. So, but most people I know in Brazil, they can drink the tap water, and many have some comments on by taste on that chlorinated compounds are there. So that would lead us, I think, to the next presenter, since he is one of the experts, not least in the drinking water supply in the city of Porto Alegre. May I thank you very much, Antonio, and we have a summary discussion at the end of the seminar. And I would like to give a word now to Dr. Rafael Newton Zanetti from the municipal water utility in Porto Alegre, who will talk about advanced modeling and maintenance of drinking water distribution networks. Please, Rafael, the floor and the screen is yours.
So thank you, Kenneth. And I will try my English too, as Antonio. and I'm just already shared my screen. Are you seeing my screen? Is it okay?
It is okay. We can see your screen excellently. If you could also give it full screen. Yes, that one.
Okay.
Thank you.
Okay. So, well, good morning for the Brazilian fellows and good afternoon for the Swedish audience. First of all, I wish to compliment the Ambassador Johanna Brisman School for her inspiring words. And then thanks to Professor Kenneth and Sweden-Brazil Innovation team for this incredible and exciting opportunity. As Kenneth said, my name is Rafael Zanetti, and I am a public servant at DMAE. DMAE is the public water and sanitation operator for Porto Alegre. But today I will share with you my view on advanced modeling and maintenance of drinking water systems, mainly in Brazilian urban areas. But again, first, I would like to share too, mainly with the audience for outside Porto Alegre, our riverbank sunsets. Just to you to know that down here in Porto Alegre, our relationship with water and the environment is strong and beautiful. Don't you agree with me? And this is why we are here today, taking this discussion. First, because although all this available water in Brazil and are in positive standards for drinking water, more than 50% of the population does not drink tap water, nor even the tourists when they come. This illustration here shows the US Center for Disease Control and Prevention advice for tourists when traveling around the world. And this tendency of not drinking tap water is increasing. As we can see, the Brazilian water market is rising almost 10% per year. And in general, water losses just reinforce this mistrust in tap water. Once population link losses with bad management and care of the system. Looking for around the country, we see that in some cities, we still need to focus in drinking water coverage, like in Northwest, like Benetti and Sergio said. However, we see that there is, in the other side, cities like Campinas in the countryside of São Paulo that even have water losses under control, where good management and practice are in place. And when it comes to slums, to tackle water losses and to guarantee quality control is even more challenging. In Porto Alegre, for example, we had established a program for, I think, like 10 years now, or a little bit more, called responsible consumption, where we reduce losses by improve water networks and connections. The community is called to use water in a rational way, and the mine install water meters for around every 50 households dealings, discussion per caption consumption with the community. One opportunity for innovation here, it's, for example, to determine how many people are there in this kind of community, to be able to discuss with the community these targets of water consumption per capita. And in this vision of my, a good example of a city that increased the population perception of tap water is Seoul. We may consider that there, local water and sanitation operator, which calls Arizu, put in place a well-established planning starting in 2007 for controlling losses in real time to get to a non-revenue water as low as 5%. Then in 2011, they announced the project for a healthy and taste water, standardizing pretty low concentrations, as we can see in the screen, for total organic carbon, for geosmine, for MIB, and then implementing what they call a dispersed dosage and control of chlorine, which low chlorine dosage at the purification plants, and using an advanced modeling of considering water quality in the system for guaranteeing a minimum residual chlorine at the whole distribution system. Sometimes even re-injecting chlorine at reservoirs and pumping stations. Again, therefore, significantly reducing what Kenneth mentioned before, this kind of unpleasant taste and odor of chlorine. Finally, in Seoul, it's worth to say that by now, they are conceding rebates for the households to refurbish their internal water mains, caring about water quality issues inside the edifications and the households, again, encourage the tap water consumption. Regarding chlorine dosage, I have received some numbers from Professor Kenneth. Stands for this same pattern, I mean, less than 0.5 milligrams per liter chlorine in drinking water distributed in Sweden. But when we come to Brazil, our standard, once we have these huge losses, is set at 2 milligrams per liter maximum, considering organoleptic aspects. In the other hand, the minimum is set at 0.2 milligrams. In sense, I mean, it is legally possible in Brazil to control chlorine concentration in a low level. We do not need to change any regulation. And of course, perhaps this will be harder in slum areas, but not in the rest of the cities. And we can handle each part of the city in a different way. But how to go to this, to progress in this vision? How to increase population trust in tap water while qualifying distribution management and diminishing losses? Looking for this case study in the city of Gothenburg, Sweden, it gets clear that implementing district metered areas and using district flow meters, in example, dividing the city into metering zones to limit the size of the area that need to be scanned actively by workers. It's more suitable than replacing pipes. Then extending leak detection efforts by increasing the number of acoustic loggers that can detect leak noise and send messages for a control center. And to establish these district meter areas with flow meters, it's almost the same as in sustainability, mainly economic. It's almost the same as increasing of personal working force for traditional leak detection methods. I mean, manual listening sticks and acoustic correlators. But the important thing here is that district meter areas is an important step forwards accurate hydraulic and quality models for drinking water systems. And this is what we need to be interested in. In Brazil, there are technical culture of modeling distribution networks. Being free, for example, and having a Portuguese version, EPA net software, it's widespread and applied. Most used nowadays, for example, in the DMAE, it's for systems pipes replacement design and check in design phase. Although EPA nets have the functionality of modeling water quality, by now in Brazil, this is not normally applied. In between others, Water Gems, a software from the Bentley System Company, have a Portuguese version too. Being a commercial software, it have tools for calibration and an easier interface with SCADA, automatization systems, for example, enhancing the real-time control and operation applications of this kind of models. They might have some licenses of Water Gems. By now, the usage of it is rising, and at least the expansion design of an important water system within Porto Alegre, the São João water system, was run using this software. Another important comment is to say that the GIS culture is too widespread within water and sanitation operations in Brazil. Of course, medium to large cities are in the forefront of this transformation. The DMAE has a well-designed GIS dataset, water systems information as consumption and pipes information, nodes, and others are all available and up to date in this GSI system. Moreover, the whole municipality or the others urban services has a well-constructed GSI dataset too, and this all information are integrated and up to date. One other innovation that the DMAE is struggling to bring to Brazil is, as mentioned, as a need for Professor Benetti, is the advanced, an idea of advanced water treatment. In this sense, last year, it was launched by Porto Alegre, by the DMAE, the Porto Alegre Wonder Water Project. It is a project that brings together the DMAE and the Federal University, represented here today by Professor Benetti. Initially, the project was focused in solving the taste and other issue faced by the DMAE and its clients in summer season, when algae bloom take place in Guaíba Lake, which is Porto Alegre's raw water source. And the plan is considering considering the conventional treatment applied today, is to test ozone as pre-treatment and checking for the potential of it to lowering chemicals dosing and sludge generation. as well as applying it together with hydrogen peroxide as an advanced oxidation process, eliminating taste and odor, oxidating organic matter, and pesticides and emergent pollutants. After the oxidation step, we are considering to apply a biological activated carbon, guaranteeing an effective depletion of organic matter, I mean TOC, and even as more specifically assimilable organic carbon, AOC. Therefore, distributing a more biostable water that we know that you guys in Europe do it for a long time now, with less chlorine demand and occurring in less biofilm building within the distribution pipes. Today, the DMAE do face turbidity increase in distributed water after pipe burst repairing, for example, and making trouble for the clients and for us, the operator. The social impact that we look with this project, we believe that once the advanced treatment gets implemented, the trust in tap water will rise. And this will be good for like, it's a kind of circular economy, and it will be good for the city, for the environment, and for the people. And it is important to notice too that initial evaluations show that not a huge water price impact will be implied with this project, with this implementation of this advanced treatment. Perhaps it not even will happen in a less water losses in distribution scenario. A pilot plant, it's to be rental. This is the plan now, following a bid, including conventional and advanced treatment equipment and operation. The DMAE is looking for a strong partner, industrial partner, to deliver this equipment in a rental way. The university, again represented here by Professor Benetti, is to set the experimental planning and critically analyzing the results of the tests. To the best of my knowledge, the funding for this project is written into the municipality budget bill for 2021-2023 periods. Another deliverable of the project is the disposal for the municipalities of a chatbot, perhaps in Telegram, for example, allowing water quality check at the more than 350 monitoring points that the DMAE has spread all over the city. It's nice to notice that CEU has a tool like this. So what next in this vision of mine? To getting to a population confidence into tap water by putting together district meter areas or district flow metering, by water distribution systems modeling, hydraulic and for quality, and to put together advanced water treatment. But what are the needs for this vision of mine to concretize? we need these DMA and DFM infrastructure development. I mean, today the level of water connections within district metering areas is not it's not enough in Porto Alegre. As I said, Campinas has a bigger a better infrastructure in this sense, and Porto Alegre and the most of the cities in Brazil, it's not do not have this infrastructure, so we need to do it. And the DMAE is looking with will for it. And another need, it's know-how. As I said, we do have some know-how in hydraulic modeling, but not in water quality modeling. So we need to strengthen this know-how and know why, as we are discussing here today, and know-how and know why to in advanced water treatment. And for sure, we are living this data revolution era. Sorry. So for sure, to have smart devices, intelligent, artificial intelligence, and well, this kind of tools, and even mainly for water quality, it's a need. So thank you all, and this I finished my presentation here, Kenneth.
Rafael, thank you very much for a fine overview of how DMI works with development of processes and treatment plants and distribution networks, and intelligence on how to develop understanding the water supply system more profoundly. We have actually got to two chat questions. I wonder if you would like to answer them. I think you would like to answer them. One question is,
for sure.
Has DMI implemented some techniques like digital twins to build a digital copy of a real network in order to improve the real-time monitoring and real-time understanding of the networks in Porto Alegre?
No, this is not true today. We do not have today. It's even hard to make a water balance. We do it. We have a lot of great technicians, but as I mentioned, the infrastructure for this kind of digital twin, it's not implemented. We need at very first to implement these district metering areas, I think. Then to move on in establishing this digital twin, and then to have advanced modeling, as I mentioned, looking for water quality, perhaps dosing less chlorine, as you had said that you feeling it when you were in Porto Alegre, it's a need. So it's a step-by-step future.
Yeah, thank you. Do you dare to guess when maybe you have got this district monitoring or district metering system developed? Do you think it will take a long time, or can it be achieved within some years?
Yes, it's something that we are already. Yesterday, I talked with our general director of our CEO, and he's saying that we are looking with will for it, but we have like 4,000 kilometers of water pipes. And even thinking to like build a district metering for like 400 kilometers a year, it will take like 10 years. It's something that we need to start, and we already started, and we do a lot of actions in this way. But again, it's I think like at least 5 years, but we can start in a part of the city. It's this like we are doing like this. We had already started. And one thing that I didn't mention, and there is a lot of other things to say about DMAE, which is a real good sanitation and water operator, but by now we have an experience of more than 10 years with smart metering. First, using like normal signals, like cell phone signals. And now we are starting to discuss IoT, smart metering. And I know that Corsan will talk about that, and they have some experience too. And well, this is an important movement, and we are taking to. And we do have already Sigfox and a lot of signals in Brazil. So I think this is important to the entrepreneurs in Sweden to know that we are able to discuss and try to implement, or as a test bed, IoT devices. So, well, what do you think?
I would be happy to, once the corona has passed over, I would be happy to participate in that development. And I'm sure there are many who would also like to co-work. I have a quick question. What do you know the domestic water consumption per person in Porto Alegre?
I think it's, well, we do treat and delivery for the city, like, I'm not sure, but like 400 liters per person per day, or a little bit less, like 350. And in summertime, this is not enough because of the losses, you know? So the thing today, it's not a matter of quantity, but this management. And because of that, we are building a new plant located in the south side of the city to handle mainly summertime, when there is a shortage of treated water, not in quantity, because as I showed, we have the Guaíba Lake just here, and it's not a matter of quantity, not of raw water quantity. Okay, but we are starting building these huge new plants in the south side.
Thank you very much, and an excellent presentation. I think we can continue the discussion at the end of our seminar, and now it is actually myself on the list, so I will go for my presentation that says coordinating the industry in the sustainable use of water. My name is Kenneth Persson. For those who maybe haven't met me before, I am professor at the University of Lund in a topic called water resources engineering, and I also work as research manager at the second biggest water utility for drinking water supply in Sweden, called South Sweden Water Supply, Sydvatten AB. And if you may take the next slide. Water is, as we have touched upon, so essential for the society, and water, as we also saw from the presentation from Anna, from Sergio Aimereas, water is essential for the economical development in society. So we need it in all aspects in our life, and in the industry, and in the public sector. Next slide. So it means that since water is everywhere, it also means that the challenges have to be dealt with by many persons, by many organizations, and since the water by itself is in a constant cycle. It runs in the hydrological cycle round and round and round. It means that so many actors affect the water amount and the water quality during this cycling of the water. I think I would like to propagate for the need for integrated water management, to put together the stakeholders, the different actors active within this cycle to participate and adding their own contribution to the different steps in order to increase water safety, increase water sustainability, improve water quality, and guarantee water quantity for the needs. So here we have on the slide is a presentation of how the process or the development wheel should look like, with setting up national goals that we heard of in the beginning from Anna from the National Water Agency, assessment of the resources and the issues that are connected with water use, develop a strategy for how to find the water resources, both quantity and quality, that is sufficient for the needs, and then get this integrated water resource management plan in place. So where we work together to actually do things, implement the actions, and then check that our actions are wise and have delivered good progress, and then we could set up even stronger, even more advanced, even more competitive national goals and let that run. We in industry, both the water supply company, the innovation companies, and definitely the utilities can participate in this cycle. Next slide. So and I give just some examples how different stakeholders have attacked, or how they have approached this challenge. And one big international company, Unilever, they work with cosmetics, detergents, some food. They have set up a very ambitious plan to be, in the long run, be a positive actor to the water cycle, so they do not cause more problems than what their products solve. And they work with the brands, the different products they sell, and how to develop the brands and develop the products, how to, in the processes, how to increase water recycling in the different factories where they manufacture their let's say, detergents and products, and also develop smarter products, let's say detergents that need less water to be used for washing. They look into the supply chain. They need raw material for production. They use different kinds of fuels and resources to the manufacturing plant, and they deliver it to the end consumer. They improve the use of water inside the factories, and they also take an active part in advocacy, in selling ideas to other stakeholders, to talk with governments and governmental authorities, to talk with colleagues in the businesses, talk with users of the products, in order to what they say, tackle wider system challenges for access, water, sanitation, hygiene. Next slide. So another thing is a country that is also a city, the country of Singapore. It's a small island, a very, very highly populated south of Malaysia in Central South Asia, as I'm pretty sure you know. Singapore is a strong economical growth engine in the area. It attracts lots of people, and it has a very strong economic development, but also very strong water use prognosis. At present, they have 1.6 million cubic meters production supply in in the country, and almost half of that is used for domestic purposes. And the estimates for the coming 40 years is that they will double the total water use, and the non-domestic, the industrial and the public side will increase more than the domestic use. And the way to tackle that, because Singapore is an island and they rely on imported water from Malaysia and from the small water resources available on the island, is to increase water reuse the water more and more. And an example is what they call new water, where wastewater is treated and upgraded to good quality drinking water, and then it's mainly used for industrial purposes. They have 3 desalination plants that produce desalinated seawater, and that is used for water supply. You can take the next slide. So it's a very intricate, very complex system where we have these desalination plants, we have these new water recycling plants or factories. Of course, they utilize the rainfall they have. They utilize the small groundwater. It's not so much, but they have some groundwater, and they increase the efficiency in water recycling. So this is set up. It's supported by the government. It's done by the Public Utility Board, the water utility of the government, PUB, and it's in a strong progress on maybe achieving a sustainable water supply system, even meeting the demands of the year 2060. Next slide, please. A third example is, as we also saw from a presentation of water use in Brazil, the biggest water use globally is water used for food production and mainly in agriculture. And if it is possible to dose the water for irrigation in a better, more precise way, then the need for water can be decreased substantially. And one example is from Israel, Netafim. They have been working with precision irrigation, drip irrigation and micro irrigation solutions to the plants for more than 50 years. And they have been able to show that they can more than half the water need for a plant, and by having a precision irrigation, giving the water to the actual plant and not to the surrounding soil. And they can also increase the crop yield by giving the substantial and sufficient amount of water to the plants that are growing. It's quite interesting and very, very promising, I would say a necessary step in when it comes to irrigation, to go to a more precise dose irrigation system, decreasing the losses of irrigated water. Next slide. One fourth example is the water supply company Sydvatten. It's a municipally owned company owned by 17 municipalities in Western Scania, from Båstad in the north to Vellinge and Skurup in the south. Lund is, as you can see, roughly a third from the bottom. So the tap water that I enjoy today is water coming from Sydvatten. It started as a company from the municipalities to invest in a tunnel, bringing water from the big Lake Bolmen in Småland and bring that down and guarantee that there's sufficient raw water for the need of the area. And that was done during the 1960s and 70s. Then the municipalities continued collaborating and helped each other in a regional water development plan. What we can see that has been taking place from the beginning of the 21st century and forward until now is that the strategic planning has been improved and has been more outspoken. So it is focus on finding the financial incentives and finding the financial resources necessary for developing the area. It is addressing, advocating, as you saw Unilever called it, addressing the needs in terms of regulation to get health and environmental permits and also do audits of these performances. It's to talk with the customers, and it's to involve all those necessary to have this chain I showed in some slides ago, this chain of actors that are needed in order to improve and guarantee the hydrology and the hydrological cycle. Next slide. So Sydvatten started with, not started, but has produced a strong strategic paper about drinking water supply challenges in a changing climate. It was presented 2014, and it presents the urgent need for regional planning on meeting the water demands on a regional level. It's not enough for the small municipalities themselves. They need to collaborate, and that's quite clear. There's a substantial need for improved monitoring water quality and water quantity, and there's a need to protect and secure the water resources and also the water treatment plants to make sure that their function and the electricity supply and so forth is in place. There is a clear need for higher flexibility and stronger preparedness to meet the changes that the climate change causes, water quality and water quantity. And also to meet and talk with customers on the demand side. What water amounts do the customers actually need, and what can be done in terms of reducing their demands by offering smarter solutions for them? Investments, and maintenance. That is central. We are working in an infrastructure area. We need to take care of the infrastructure that is used to supply the water. Talk about the water safety, do public relation information campaigns, and of course, which I'm very fond of, do more research and work with development innovation. Next slide, please. The work, and of course, together with lots of other works, led to a program called Strategic Plan for Sydvatten AB that was decided by the board of directors 2 years ago, 2018. And in that strategic plan, that has a planning horizon for 10 years from 2020 to 2030. There is an estimated investment need during those 10 years on about 400 million euros, a little bit more than 450 million US dollars. And the list, they come back, as we saw from the climate change demands. We have a security and quality plans. We have competence, how to find right people to work with the organization, how to deal with environmental changes, how to guarantee a good economic stability for the company and for the municipalities that own the company, how to deal with sustainability challenges, and how to engage with the other stakeholders, external partnerships, and the society in order to get them interested in and get them aware of the need of good water supply and good water quality. And of course, look into how can the business be developed and how can what kind of new strategic decisions must be taken in the plan. So that one was further on refined in terms of sustainability. So may I ask for the next slide? So we had a sustainability plan that came as a kind of spin-off from the strategic plan. And that was developed based on the strategic development goals, the United Nations SDGs. And it's mainly 6 goals that are of central concern for Sydvatten. It's the health, education, good water and sanitation, energy, sustainable production and consumption, and climate change effects. So that has also been implemented. If I may ask for the final slide. Okay. Last year, there was a complementary investigation on how can Sydvatten work together with all the stakeholders, not least national stakeholders, in order to improve not only Sydvatten's water planning, but the national water planning. And it came as a report, Climate Safe Water, with strong and very clear suggestions for how to improve national level regulations, regional level regulations, and municipal level actions to make sure that there is a coordination from the water industry for the sustainable use of water. So that concludes my presentation, and I'm curious if we have any comments, questions from the audience. Q&A. No. Water consumption. Yes. That means, excuse me for talking too much. I am the moderator, so I have to blame myself. But we gather back again at 11:15 in 8 minutes from now in Brazil, and in 15:15, a 3:15 in Swedish time. Thank you so much for this part. Thank you, Rafael. Thank you, Antonio, for excellent presentations. See you in 8 minutes.